Hello everyone, welcome to Unique Beam. In this video, we turn our gaze to Mars, the red planet, which has captured the human imagination for centuries. Mars is not just a destination for rovers and satellites, it's the centerpiece of humanity's ambition to expand beyond our home planet. As we look toward a future where Mars might one day bloom with life, the concept of terraforming, transforming an alien world to support Earth-like life, becomes not just science fiction, but a vision that could potentially become reality. Join us as we explore the possibility of turning the arid, cold desert of Mars into a green, habitable world where humans could live and thrive. The journey to a habitable Mars challenges our ingenuity and science. It invites us to envision a bold future where interplanetary life is commonplace and where humanity has left a green footprint on another world. As we dive into this exploration, we will discover not only the scientific possibilities, but also the profound impact such a project could have on our identity as a civilization. Terraforming, a term coined in science fiction, has made its way into the lexicon of astronomers and planetary scientists. At its core, terraforming involves altering the environment of a planet to make it habitable for Earth-like life. This monumental task includes modifying the atmosphere, temperature, surface topography, and ecology to support human life and other Earth species. For Mars, this means warming the planet, thickening its thin atmosphere, and possibly introducing water and organic material to cultivate its barren lands. The idea is based on the assumption that Mars once harbored flowing water and possibly life, as suggested by numerous missions that have identified water ice and ancient river valleys on its surface. By reviving these dormant conditions, scientists believe we can make Mars a suitable second home for humanity. But how do we achieve such a feat? This question leads us into discussions of advanced technologies and groundbreaking science that might make terraforming Mars a reality in the centuries to come. The concept of terraforming Mars has evolved from the realms of pure fantasy to a serious scientific discussion. Early science fiction writers like H.G. Wells and Ray Bradbury imagined Mars as a world teeming with life where humans could walk freely and start anew. These stories laid the groundwork for public interest in Mars, which gained scientific backing in the mid-20th century when Carl Sagan first discussed the possibility of terraforming Venus and Mars in a scientific context. Since then, the idea has been taken up by numerous scientists and entrepreneurs, each bringing their own vision and proposals for making Mars habitable. From theoretical studies in planetary science to detailed simulations and discussions at space agencies around the world, the idea of terraforming Mars has grown into a complex field of study that encompasses atmospheric science, astrobiology, planetary geology, and environmental ethics. As we continue to send missions to Mars, each providing new data, the dialogue on terraforming becomes increasingly nuanced and rooted in emerging scientific realities. Before we dive into the atmospheric challenges and innovative solutions for terraforming Mars, let's take a moment to connect. If the idea of transforming the red planet into a habitable world captivates your imagination, be sure to subscribe to Unique Beam and give this video a thumbs up. Your support fuels our exploration of these ambitious possibilities, bringing the future of space exploration closer to you. Now, let's explore the immense challenges Mars presents and the cutting-edge technologies that could one day turn this red desert into a thriving, green world. One of the most formidable obstacles to terraforming Mars is modifying its thin atmosphere. Mars's atmosphere is primarily composed of carbon dioxide with traces of nitrogen and argon, but it is less than 1% the density of Earth's atmosphere at sea level. This poses significant challenges, not only for human respiration, but also for protecting inhabitants from solar and cosmic radiation. Moreover, the current atmospheric pressure on Mars is so low that liquid water cannot persist on its surface. It would either freeze or evaporate almost instantly. To create a breathable atmosphere and allow for liquid water, Mars would need a significant increase in atmospheric pressure and a composition change to increase oxygen levels. This could theoretically be achieved by releasing gases currently locked in the planet's soil and polar ice caps, possibly through processes like sublimation or chemical reactions driven by intense heat or nuclear explosions. However, managing such a transformation poses immense technological and energy challenges that push the limits of our current capabilities. The presence of water on Mars is crucial for terraforming, as water is essential for life as we know it. Fortunately, Mars hosts abundant ice, particularly at its poles and beneath its surface soil, which could potentially be converted into liquid water if the planet were warmed significantly. The evidence of ancient riverbeds and minerals that form in the presence of water also suggests that Mars once had flowing water and perhaps even oceans. To utilize this ice, terraforming efforts might involve heating the planet to melt polar ice caps and underground glaciers, a process that could also help thicken the atmosphere through the release of carbon dioxide and water vapor. Strategies such as orbiting mirrors to reflect sunlight onto the Martian surface, creating a greenhouse effect, or even deploying nuclear devices to initiate warming are among the ideas proposed to initiate this massive environmental change. The technology required to terraform Mars includes a wide array of engineering marvels and innovations. One proposal includes the use of giant space mirrors that would direct sunlight onto Mars's surface to increase temperature and initiate the release of carbon dioxide from the soil. Another involves introducing genetically engineered microorganisms capable of surviving Mars' harsh conditions to begin producing oxygen through photosynthesis. Additionally, manufacturing technologies that could process Martian materials into resources necessary for human survival, such as breathable air, water, and construction materials, are critical components of a terraformed Mars. These technologies would not only help create a habitable environment, but also support a self-sustaining human presence on the planet. Terraforming Mars raises significant ethical questions. The most pressing of these is whether we have the right to alter another planet fundamentally, especially considering the possibility, however remote, that Mars could harbor life. Altering Mars' environment could potentially wipe out indigenous life forms or alter them irreversibly. There is also the question of the immense cost and who would control the terraformed Mars. Practically, the timeline for terraforming Mars spans centuries, if not millennia. The technological, physiological, economic, and environmental challenges are enormous and require international cooperation and unprecedented scientific breakthroughs. These factors make terraforming Mars not just a scientific endeavor, but a multi-generational legacy project that would extend beyond our current technological and ethical boundaries. The dream of turning the red planet green is a testament to human ambition and ingenuity. Terraforming Mars represents one of the most colossal and inspiring challenges humanity might ever undertake. As we continue to explore Mars and develop the technologies that could one day transform it, we also delve deeper into what it means to be human and our place in the cosmos. Whether or not we decide to pursue terraforming, the discussions and innovations spurred by this grand vision will undoubtedly influence our approach to space exploration and planetary science for decades to come. Thank you for joining Unique Beam on this exploratory journey into the potential future of Mars and human civilization. If you're inspired by the possibility of transforming distant worlds, don't forget to subscribe to our channel and like this video. Your support helps us continue to bring you the most exciting developments from the frontier of space exploration. Keep dreaming big and keep looking toward the stars.